Welcome to Civil Engineering Edge, your trusted platform to learn engineering concepts in the simplest way possible. Today, we will explore one of the most important components in building design, stairs. A staircase not only ensures vertical circulation, but also plays a crucial role in safety, aesthetics, and space planning. In this video, we'll discuss the requirement of stairs as per its code, the design criteria, classification, and benefits of different staircases. By the end of this session, you'll have a clear understanding of stair design fundamentals in civil engineering. Let's begin with the basics. Have you ever climbed a staircase that felt too steep, too narrow, or just uncomfortable? That's not just poor design, it's a violation of essential standards. Stairs may look simple, but in engineering, their design follows strict guidelines for comfort, safety, and usability. From rise and tread proportions to headroom clearance and landing width, everything is governed by its codes to ensure accessibility and efficiency. Whether it's in homes, schools, hospitals, or high-rise structures, stairs remain one of the most used building elements. Let's understand the science behind stair design as per is requirements. Requirement of stairs as per is. According to is 456 to 2000 and related is codes. Staircases must fulfill both functional and safety requirements. The primary purpose of a staircase is to provide easy and safe vertical movement between different levels of a building. Key requirements include comfortable rise and tread. The rise vertical height of a step should generally be between 150 millimeters to 190 millimeters, while the tread horizontal portion should be 250 millimeters to 300 millimeters. This proportion ensures both safety and comfort. Width of stair. For residential buildings, the minimum stair width is 1 meter, while in public buildings, it should be at least 1.5 meters to accommodate higher foot traffic. Headroom. A minimum headroom of 2.1 meters is recommended for safe passage. Landings. Landings should be provided after 12 steps for comfort and should have at least the same width as the staircase. Handrails. At least one side should have a handrail at a height of about 900 millimeters to 1000 millimeters. Thus, the IS code ensures that staircases are safe, functional, and user-friendly, preventing accidents and ensuring compliance with building standards. Design of stairs as per is. The design of staircases in civil engineering is a crucial aspect of building planning, since stairs not only facilitate movement between different levels, but also act as structural elements that must withstand various loads safely. According to is 456 to 2000. The design process involves the key aspects: dimensional planning for user comfort and structural design for load-bearing capacity. 1. Dimensional requirements, geometrical design. The comfort and usability of stairs are determined primarily by the proportion of rise and tread. The Indian standard suggests that the riser should ideally lie between 150 millimeters to 190 millimeters, and the tread T should be a minimum of 250 millimeters. A commonly applied rule is the empirical formula 2R plus T equals 550 to 650 millimeters, which ensures natural and fatigue-free walking. This proportion is mandatory to prevent staircases from becoming too steep or uncomfortable. Other dimensional requirements include width of stairs, minimum 1.0 meters for residential and 1.5 meters for public buildings. Headroom, minimum 2.1 meters clear height. Landings, provided after 12 consecutive steps, with width equal to or greater than stair width. Handrails, positioned at 900 to 1000 millimeters height for safety. 2. Structural design load consideration. Once dimensions are finalized, stairs must be checked structurally to withstand applied loads. IS code specifies that the design must account for dead load, self-weight of the stair slab, and finishes. Live load for residential buildings, usually 3.0 kilonewtons per square meter. For public buildings, higher values are adopted. Impact loads and additional loads, considered for safety in areas with heavy usage. Stairs are usually designed as slabs spanning between supports as cantilever slabs, or as beams depending on architectural layout. The reinforcement is detailed as per IS 456 provisions, ensuring proper spacing, cover, and anchorage. 3. Materials and detailing. Reinforced cement concrete, RCC, is the most widely used material due to its strength, durability, and flexibility in design. Adequate cover is essential to prevent reinforcement corrosion, and stair surfaces should be treated for slip resistance. Proper detailing at landings and supports ensures smooth transfer of loads to beams, walls, or columns. 4. Safety and serviceability beyond strength. The IS Code also emphasizes serviceability criteria, ensuring no excessive vibrations, deflections, or cracking in stairs. Handrails, balusters, and finishes are integral to safety and usability. In summary, the design of stairs as per IS Code is a balanced process of ensuring dimensional comfort for users while also guaranteeing structural safety. A well-designed staircase, compliant with IS 456-2000, provides not only functionality, but also longevity and architectural appeal. In conclusion, the IS Code emphasizes not only dimensional accuracy for user comfort, but also structural safety to resist applied loads. A well-designed staircase combines both aesthetics and engineering, ensuring durability, safety, and convenience. Classification of stairs and their details. Stairs can be classified in civil engineering based on their layout, geometry, and functional use. The choice of staircase type depends on available space, building requirements, cost considerations, and architectural aesthetics. Below are the common classifications as per practice and IS recommendations. 1. Straight stairs. The simplest form, consisting of a single flight without a change in direction. They are easy to construct and suitable for small residential houses, but require more longitudinal space. 2. Dog-legged stairs, made of 2 flights running in opposite directions, connected by a landing. This type is very common in apartments and office buildings as it saves space and provides compactness. 3. Open well stairs, similar to dog-legged stairs, but with a central opening or well between flights. The opening can be decorative or used for ventilation, making these stairs more spacious and visually appealing. 4. Quarter-turn and half-turn stairs. In quarter-turn stairs, the direction of flight changes by 90, while in half-turn stairs, the change is 180. These are used where space is limited and are highly functional in multi-story residential and institutional buildings. 5. Spiral stairs. Constructed around a central post with steps arranged in a spiral form. They occupy minimum space, making them ideal for emergency exits or small areas. However, they are not suitable for heavy traffic or elderly users. 6. Helical stairs. Similar to spiral stairs, but without a central support post. They are aesthetically elegant and often used in modern architecture where design appeal is essential. 7. Bifurcated stairs. Common in public buildings. These start as a wide flight at the bottom and split into 2 narrower flights at a landing above. They enhance grandeur and allow smooth circulation of large numbers of people. Each staircase type has its unique advantages, from space-saving spiral stairs to aesthetically rich helical stairs and functional dog-legged stairs. Selection depends on the functional requirements, available space, and architectural intent of the building. Benefits and conclusions. Stairs are much more than just a means of vertical circulation. When designed as per IS standards, they ensure safety, minimizing risk of accidents through proper rise, tread, and handrails. Comfort, easy and fatigue-free movement for users. Durability, strong structural design ensures long-lasting performance. Space efficiency. Proper classification allows optimization of available space. Aesthetic value. Different layouts like spiral or helical stairs enhance building design. In conclusion, staircases form an essential element in building construction. By following his guidelines, civil engineers can achieve a perfect balance of safety, usability, and design appeal. A well-designed staircase not only supports movement, but also elevates the overall architectural character of the structure. That wraps up our discussion on the requirements, design, classification, and benefits of staircases as per his code. We hope this video helped you understand the importance of proper stair design in civil engineering. If you found this explanation useful, don't forget to like, share, and subscribe to Civil Engineering Edge for more insightful content. Also, drop your questions or topics you want us to cover in the comments below. We'd love to hear from you. Until next time, keep learning, keep building, and keep engineering the future. Thank you for watching.